In the realm of large language models and artificial intelligence, prompt engineering is a vital field encompassing a variety of techniques, including few-shot learning, chain of thought, and retrieval augmented generation (RAG). Let's explore these techniques, their applications, and the potential in illustrating the true capabilities of large language models in various fields. As usual, we will load up our models, store the API keys, and specify the large language model that we would like to use. When formulating prompts, you can effectively guide the model by using clear commands such as write, classify, summarize, translate, order, complete, and so on. Language models, built on years of research and programming, are trained to understand these simple commands. Let us consider the following examples. Here we exploit the predictive nature of the model for sentence or paragraph completion. This is valuable for creating content like books, documents, movie scripts, and so on. With Classify, we can use the model to analyze words or sentences. Based on the context, we can perform sentiment analysis, as evident from the response. We can also perform translations, for example from Arabic to English or English to Italian, or even translate into programming languages, from Python to Java for example. Finally, we can summarize texts, books, and of course, company documents if required. After understanding how to formulate simple commands, let us delve into the complex process of prompt engineering. At this point, I would like to emphasize that our goal here is not to compare large language models or AI models to human capabilities, but to explore how we can use these models to automate our work and make our lives easier. Zero-shot prompts. This involves the model's ability to produce responses based solely on its pre-existing training data. And as we've seen with the classification example, the model seems to infer sentiment analysis without being given any context. Few-shot prompts. This is like providing someone with a set of examples before asking your final question. This step can help the model better understand your question and respond accurately. Let us try an example without any context and see how we can improve it. Now, it's clear that without providing any context, the model tends to give general answers. However, by presenting some examples or guidance, you can steer the model towards providing the responses that you desire. This method can be applied across a wide range of scenarios, from simple queries to complex mathematical formulas, SQL statements, text analysis, and so on. As you can see, these interactions allow you to extract context-specific responses, enhancing the model's utility in various applications. Chain of thought. This technique enables the language models to engage in complex thinking by bypassing some intermediate steps before arriving to the final solution. And this method can be used in two ways: as a standalone question, zero shot, or in parallel with examples, few shots, to achieve results in tasks requiring pre-response thinking. Let's start with a simple example, asking a model for the fastest way to get to work. Now, based on the model's capabilities, you might get the correct solution without any guidance, or, as you can see, an incorrect one. However, when we give an example using chain of thought, we get the appropriate response because we have provided the necessary instructions to reach the solution. Now, let's apply this technique to a customer support service call. As you can see, without providing any guidance, the model can't give us the required answer. So we can't really use it in an application that relies on it for work. But after giving it some examples and guidance, we start getting the required answers. And if we use this within an application where this process is automated with hundreds and thousands of transcripts, we would start to get the required answers within a few minutes. However, beware, when you engineer prompts, you must always consider what happens if the model cannot find what we're looking for, as in most cases it will attempt to hallucinate the response. Therefore, you must give it the necessary guidance. For example, we would say, find the DPA questions, or else say, no questions found. As you can see, the difference between a trivial chat program and an application that helps automate tasks lies in prompt engineering and prompt tuning. Speaking of prompt tuning, let us explore an alternative scenario. Imagine this is part of a specific application, and inside this application you can direct the model to deliver results in formats that seamlessly integrate into programming processes. For example, we can create conditional statements like true and false, or even get outputs using structured data like JSON, XML and SQL, which can then be seamlessly integrated into subsequent programming operations. This level of prompt tuning ensures that the model aligns with your specific business needs, allowing you to exploit its capabilities in a way that increases the efficiency of your application. As you can see, instead of being given a conversational response, we now have a response using JSON format, and through it we can extract what we need and use it in our application. Of course, this scenario is not easy to achieve, but it's not impossible, as I've managed to program such an application. Typically, we need a complex network of directives, and based on the capabilities of the model used, changing these directives can lead to varying degrees of success. I would recommend to use a strategic mix of chain of thought with system and user commands for few-shot, meaning we use system commands to give behavioral guidance and then reinforce it through illustrative examples. When experimenting with different texts, don't hesitate to present several inquiries at once. So you could say your tasks are as follows. It will work as long as your tasks don't require unique chain of thought operations. And in that case, I would advise to split the interactions. As you add more behavioral commands and prompts, you may encounter cases where the model's response is unexpected or is not giving you what you're looking for. Here are some unconventional tips to improve its performance. Assign a unique identity. This can be X, potato, or any other name, and refer to it during your interactions. By referring to the identity, you have helped reinforce the basic directives without repeating them. Be polite. Politeness can contribute significantly to better responses, so remember to say please. And lastly, encourage the model to take a moment to process complex tasks, as this can lead to more accurate results. For example, we'd say, please take a deep breath and think step by step. Your tasks are as follows. Now let's change the previous example by eliminating all few shots and just use chain of thought with some behavioral commands tied to a specific identity. As you can see, it works perfectly. Grand, so that's all for me. I hope I piqued your curiosity and I encourage you to experiment on your own.